All right, let's get started. So, this goes back to like the very first week of school where you have a piecewise function. And remember, the whole point, I would say, probably of Algebra 2 is that it prepares you to look at data. Okay, the data kind of runs the world. And so a lot of really good jobs out there have data, but data can come in pieces, right? It's not always going to be just a smooth function. So here we have a line, then we have a quadratic, but the question isn't asking for the equation, it's asking for the range. All right, so if you remember the range, let me just grab a little. Okay, the range goes from the lowest to the highest. Okay, so don't get confused with range and domain. Okay, they're very different. Domain runs this way. It's going to go from left to right. Okay, so the range goes from lowest to highest. And so what we do is we just try to ascertain what is the lowest y coordinate that we're going to have out of both of these pieces. You can see here that -3 looks like it is touched. Okay, so it looks like -3 is the lowest because none of our arrows are pointing downwards. So -3, and then it just keeps going up. And it looks like this arrow kind of dominates, and he's just going to continue on. So our range, you can write this in two different ways. I'm going to write both. You can go from -3 to infinity, which I think is the easiest way to write it. Or you could have written it as all x such that x is greater than or equal to -3. Okay, either one is just fine. All right, now the domain is going to go from left to right. So left, with this arrow basically dictates that it goes to -infinity. And as we move across, you'll notice that there is a hole, but this hole is filled in here. So if this guy would have been right there, we would have had two separate pieces in our domain. But because he is lined up exactly with him, at -1, the x value does have an output, and it is -2. So this guy keeps going, no holes, and this guy it is assumed that this guy just keeps going. Even though he gets really, really large, he will continue to go to positive infinity. All right, now the intervals where the graph is negative. Now you'll notice here that we're in a position here where everything that is below the x-axis is negative. Everything above it is positive. And so the interval where this graph is negative is actually this piece right here. Okay, this guy right there. Now, if we look at this, then it looks like whenever you talk about intervals being negative, positive, increasing or decreasing, you always talk in the domain. All right. Now this guy is negative from -1 all the way to whatever this value is right here. Moving across from -1, not this one, but this one. He's negative from -1 all the way to here. Now I'm going to have to estimate that. That looks like about 1.8. So I'm going to go from I am negative from -1, and then as soon as I get to 1.8, okay, I will not include him because he is 0 there. Okay, so that is just an estimate, and that's perfectly reasonable. Now the reason why I put brackets here is because -1 is absolutely negative. All right, he's not right there at the threshold. All right. So if this guy would have been here, then I would have had to put in open parentheses. Okay. All right. So what is the average rate of change? And the average rate of change is always the slope. And I think this is almost everyone got this wrong because you guys, it just you forget to bridge the two. Slope is the rate of change, and it's the average rate of change. Okay. So the average rate of change is going to be from 0 to 2. So what you do is you go to 0 on the function. The 0 has a value here, so it's from here, and then to 2. So 2 has a value here. Okay, so right there. Now the average rate of change is the slope from here to here. It's just that slope. It's the rise over run. And you can see here that I don't even need a slope formula because I actually got those 2 points, and because it's a graph, I can count. Okay, so this guy from here to here, it went up 1, 2, 3, 4, and then it went over 2. So the average rate of change is 4 over 2, which can simplify to 2 over 1, which is just 2. That is the final answer. All right. So Next, where we at? Oh, yeah, we got plenty of time. We'll probably do this whole page here. The graph of this absolute value. Now, the absolute value, you have to remember that the absolute value is V-shaped. Okay, you got to look that up. Put it on your note card if you can't remember. But it's very important that you remember that the absolute value is V-shaped, quadratics are U-shaped, and lines are obviously lines. Or linear functions are lines. Alright, so the graph of this guy has got a lot going on. He's got a movement to the right or left, and he's got a movement up or down. And then this says that it is reflected across the x-axis. Okay, the graph of this guy is reflected across the x-axis. So this means this guy was already reflected, and now we're going to reflect them back. Okay, so what is the reflection of the reflected graph? Let's draw him. Okay, let's see where he is at. Now he's going to move to the right, 3, okay, because remember, on the inside of parentheses, just like in vertex form of quadratics, if I have a negative sign here, it means I'm moving to the right. If the negative is outside the parentheses, this means that I'm moving down 4, okay? So this guy, all right, and this means he's pointing downward. So he's got all this going on, and then we're going to reflect him, and then we're going to have to determine which one of these shows that reflection, okay? It isn't just about erasing this. Sometimes you have to be careful because now he's negative if he's going to have to go up instead of down. So let's look at this. Okay, now I'm just going to draw a basic sketch where I move to the right 3, 1, 2, 3, and then I go down 4, 1, 2, 3, 4. All right, so he's right here, and this guy points downward. Okay, now remember, I'm just doing a basic sketch because I want the guy, and I'm going to switch colors here, I want the guy to go 1, 2, 3, 4 up. I need him reflected on the x-axis. Okay, this is the x-axis, so this guy has to point upward. Okay, we need to flip him. Now, where is this guy? Now, clearly he's moved over to the right 3 still. Okay, but he's moved up 4. Okay, he's moved up 4, and he is pointing upward. So I need these 3 conditions to show the reflection of him right here. Okay, so which one does that? This guy is right 3, up 4, and he is pointing upward. So it looks like it's got to be this guy. This guy's still pointing downward. This guy's still pointing downward, so those guys are no good. This guy's pointing... what's the difference between these two? Nothing. B or D. B or D is good. I think I meant to make this a -4, a -4. All right, so B or D is absolutely acceptable because they're both the same. All right. So let's find out about Charles here. Charles is carefully emptying a 120 cubic foot bucket of toxic chemicals, poor Charles, at a rate of 1/3 cubic feet per minute. What is the domain of the situation? All right, so let's think about this. He's at 120, okay? At time 0, he has a full bucket. He's got 120, but he's emptying it. So this means that if I were to graph the volume over time here, okay, how long is it going to take? How long is it going to take for this thing to empty, right? I can't have negative volume of a bucket, okay, or negative toxic chemicals. All right, so I'm going to have to stop right here, okay? All right, I empty it out, but the rate is a constant rate, 1/3 cubic feet. So what I have to think of is that every single time, every minute I get 1/3. So that means every 3 minutes I lose 1. Okay, every 3 minutes I lose 1 cubic foot. This thing is getting poured out very slowly. Okay, so if you think about it, then you have to think, well, 1/3 times what is going to give me that 120. Okay, and so this is kind of a practical way of looking at domain. Okay, my domain has to go here, but I need to know where does it actually run out. And you have to think about what value of time multiplied by that rate is going to give me the actual amount that I started from. So I multiply both sides by 3. Okay, multiply both sides by 3, and I get 360. Okay, so in 360 minutes, that means that I'm going to have an empty bucket, like that toxic chemical will be finally spilled out. Okay. What you can do is you can also think to yourself, okay, and then this is how much I had at time 0, and then after 3 minutes, I go down to 119. Okay. After 6 minutes, I go down to 118, and just kind of think, okay, where's that going to take me? Okay. And then if you keep going, you would not go that. You just need to find the pattern. And you'll notice that, yeah, if I multiplied this guy by 3, that's what's going to take me to 360. Anyways, the domain then, you start off at 0. You start off at 0 for time, the beginning time, and then at 360 is when it finally empties out. Okay. Now, if you include 360, I think that's better. Okay. All right. All right, we're at the 10-minute mark, and we'll stop there for 7. We'll do the next time.